So there are many contexts in which you might want to know the average rate at which a function is changing. It's called the average rate of change of a function. Perhaps you might want to know how quickly the air temperature is dropping as a storm is approaching, or how fast your revenues are increasing when you have a new product. So average rate of change can actually be defined for any function at all. And so with the definition, it looks quite complicated, but it's nothing more than just the slope of a line. If you pick 2 points on your function, say this point, and then draw the line that connects those 2 points, that line right there, which I sort of missed, but that line right there, that's called the secant line. Secant line. And the slope of that line is what the average rate of change of the function is as x goes from a to b. So it's an indication of how steeply the graph is rising or falling, because it's a slope. And so it's calculated just the way the slope of a line is calculated, the difference of y coordinates divided by the difference of x coordinates. And so it's a simple matter to determine the net change and the average rate of change. The numerator is the net change, and when you divide by the difference of the x coordinates, you have the average rate of change. And sometimes it's easy to see this from the graph of a function, so you can actually find the slope of this dotted line here by doing your rise-run. So if you start at this point on the graph, you would go up 2 units, so that's a rise of +2, and you would go to the right 3 units, so that's +3. So the slope of that secant line is 2/3, and that's the average rate of change. The net change is 2, because as x varies from 1 to 4, the function values increase from 3 to 5. So that's a net change of 2. So there's the net change. And when you divide that by the change in x, you get the average rate of change. It's pretty easy to do that from the graph. Here we have, starting at this point, we'll have to go down 2 units. So that's a rise of -2. And then a run of +4. So rise over run is -2 over 4. And that's your average rate of change on the interval from x equals 1 to x equals 5. Notice that -2 is the net change because the function values decrease from 4 to 2 as x varies. So that's a decrease of 2. -2 is the net change. So I'll let you practice doing this one and this one graphically. To do these algebraically, it's just a matter of using the definition. So to find the net change of this function on this interval, you would find h of 4 minus h of -1 divided by 4 minus -1. Well, h of 4 is 4 squared plus 2 times 4 minus h of -1. So with that minus sign, we have to use a grouping symbol because there are going to be 2 terms. H of -1 is -1 squared plus 2 times -1. So that's the numerator. And the denominator is 4 minus -1, which is 4 plus 1, or 5. So you can work this out. Do some simplifying. So 4 squared is 16. 2 times 4 is 8. 16 plus 8 is 24. Minus, what do we have in here? This is 1, and this is -2. 1 and -2 is -1. So the negative of -1 is +1. So that minus is going to become a plus. A plus 1 divided by 5. 24 plus 1 is 25, and 25 divided by 5 is 5. So we get 5 as the average rate of change of that function. I'll let you do the next one, and I'll let you do this one as well. This one actually we'll do together here. Recognizing that a function with a constant rate of change is linear, find the average rate of change between x equals a and x equals a plus h. So we're going to calculate f of a plus h minus f of a divided by a plus h minus a. Now, f of a plus h means 1/2 a plus h plus 3 minus 1/2 a plus 3. We need these grouping symbols again because of that subtraction sign. The denominator a plus h minus a just becomes h. So here we have 1/2 a plus 1/2 h plus 3, and then minus 1/2 a and minus 3. And all that is over h, over h. Now we have a 1/2 a here and a minus 1/2 a there. That adds up to 0. A plus 3 and a minus 3, that adds up to 0. And so that leaves us with 1/2 h over h, and the h's reduce, and so we finally end up with 1/2. So that was pretty cool. So this is doing a rate of change problem just from data. We have a table that gives the population in a small community from 1997 to 2006, and we see that we want to know what's the average rate of change of the population between 1998 and 2001. Well, the average rate of change between 1998 and 2001 involves these 4 numbers. These are the function values, the y's, if you will, and these are the x's. And so we'll have 1,591 minus 856, the difference of the y's, divided by the difference of the x's, 2001 minus 1998. So that's just some arithmetic you can do. And then you can do from 2002 to 2004, you would just use different numbers. 2002 and its function value, 2004 and its function value, and do that same calculation. And then for the period of time during which the population is increasing or decreasing, well, we see that the population starts at 624, and then it increases. So it increases from 1997 to 2001, and then it decreases from 2001 to 2006.